I'd like to welcome all the participants to today's webinar on behalf of the PETA International Science Consortium and to thank Chemical Watch for their support in hosting these webinars. The goal of this 6-part webinar series is to help registrants plan for the 2018 REACH deadline. Hundreds of thousands of animals have already been used for REACH testing, and millions more are expected to be used in the coming years. However, there are numerous alternative methods that can be used to meet REACH data requirements while minimizing animal testing. With this in mind, our Science Consortium has made minimizing animal testing for REACH requirements a high priority. If you check out our website, you'll see that we have a page dedicated to promoting alternative methods to meet REACH requirements, and also on our website, you'll find recordings of all past webinars in this series, including the last webinar on the OECD QSAR Toolbox and Read Across. I'd also like to let you know that our scientists are available to assist registrants in avoiding animal testing, so please feel free to get in touch with us if you are interested in more information on how to use the methods discussed during these webinars. Today, we will be presenting the second webinar in our series, which is focused on alternative methods for skin irritation and corrosion testing. The speakers are Dr. Emilia Costin and Costanza Rovida. Dr. Costin works as a toxicologist and study director at the Institute for In Vitro Sciences, a nonprofit research and testing laboratory dedicated to the advancement of in vitro methods. Dr. Rovida works as a scientific officer at the Center for Alternatives to Animal Testing in Europe and as a project manager for REACH Mastery, a REACH consulting firm. With that, I'll pass the controls over first to Emilia.
Hello, everyone. Thank you for participating. I will walk you through the regulatory accepted assays for skin irritation and corrosion. Next slide, please. The overview of my presentation consists of a discussion about the impact of test substances on human skin. I'll briefly present on the animal test system used for skin corrosion and irritation. I will introduce the in vitro assays used for the evaluation of the two endpoints, and I will end the presentation with testing strategies. Next, please. First topic, the impact of test substances on human skin. Next, please. Skin is a very complex tissue and organ that represents a vast physical barrier against mechanical, chemical, and microbial factors. It's also an immune network and a unique defense system against UV radiation. When a skin corrosive or irritant is come in contact with the skin or is applied, two events can take place at different time points. Corrosion, on the left side of my slide, is the irreversible damage of the skin following the exposure to the test substance, and it's visible through ulcers or bleeding. Irritation is the reversible damage of skin following the exposure to a test substance and is characterized by erythema and edema. When these events occur on the skin, and it's very important to appropriately label and register the chemicals also for transportation purposes, for occupational safety purposes, and to assess the safety of cosmetic toiletries and other substances. Next, please. Just briefly to discuss the animal test system that you may be familiar with, the Draize test. Next, please. The test system uses albino rats, two endpoints, erythema and edema. And this particular test is used to evaluate the corrosion and irritation potential of test substances and has an OECD test guideline approved number 404, lastly updated in 2002. Keeping in mind that the rabbit and human skin have different physiological properties and therefore some substances may be more toxic to rabbits than to humans, scientific community try to come up with new assays, particularly in vitro assays, to avoid animal experimentation and to avoid animal suffering and discomfort during testing. Next slide, please. Just briefly, not to go into the details of the scoring system, the Draize test uses up to 3 rabbits, and any test substance can be tested solid or liquid. The animals are evaluated up to 28 days for the two endpoints, erythema and edema, and the score is calculated. Next slide, please. Introducing in vitro assays used for skin corrosion and irritation. Next, please. When assessing the skin corrosion and irritation, we have to keep in mind that the impact of test substances on skin is evaluated progressively from corrosion and irritation to potential to human compatibility. Usually, the shortest exposures are typical for corrosive or severe irritants, and for this purpose, various assays are available depending on the final goal of the testing. For skin corrosion, there are 3 regulatory accepted assays, the transcutaneous electrical resistance test, reconstructed human epidermis test method, and the Corrositex method. And for skin corrosion, again, the reconstructed human epidermis method. I'm going to walk you through the technical details of how these assays are performed. Next, please. This is an overview of the native human skin structure, and by comparison, all the models that are currently available commercially to be used for to conduct the skin corrosion and irritation testing. These models have to comply to general criteria and functional criteria. They come with a QC from the manufacturer, and they have to have a functional structure and also stratum corneum. Next, please. For in vitro skin corrosion assessment, there are 3 assays available. We're going to start with the T-tier testing. Next, please. This test system uses red skin discs from Wistar-derived strains. The assay endpoint is the electrical impedance of the skin expressed as resistance, which is a measure of the barrier function. The assay is used to identify non-corrosive and corrosive test substances and mixtures in accordance to GHS system. It has a limitation, though, because it does not allow the self-categorization of corrosive substances and mixtures based on the GHS system. The guideline for 430 was lastly updated last year. Next, please. In brief, this is how the assay is performed. The skin discs are prepared as outlined in the test guideline. Each disc is placed on the epidermal surface, in contact with the tube that is detailed on the left side of my slide. The test substances are applied to the epidermal surface for a 24-hour exposure. At the end of the exposure, the test substance is removed by washing with water, and the skin resistance is measured. Usually, there is a cutoff of 5 kiloohms for the cutoff that differentiates between corrosive and non-corrosive materials. In the prediction model outlined in the table on this slide, you can find the exact cutoff values and how a test substance is labeled corrosive or non-corrosive based on this particular method. Next time, please. Next method is the RHE Test Method used for skin corrosion. The test system that can be used are four tissue models from different manufacturers. The assay endpoint is tissue viability assessed by the reduction of the vital dye MTT by viable cells. The method can be used for regulatory purposes to distinguish corrosives from non-corrosive substances. One of the limitations is that currently only EpiSkin of the 4 models can be used to support subcategorization of corrosive test substances, whereas the other 3 models are not able to differentiate. The guideline 431 was updated this year in September. Next slide, please. In brief, this is how the assay is performed. The tissues are received at the end user facility, and they are incubated in standard culture conditions for at least 1 hour. Duplicate tissues are then transferred into fresh media and are treated with the test substances for the exposure times that are specific to each tissue model. After the exposure, the tissues are rinsed with DPBS to remove the test substance and the control. The tissues are placed into wells containing the vital dye MTT, which is reduced by viable cells within 3 hours. The MTT is then is extracted in isopropanol for 2 hours. And the extracted MTT and isopropanol is then plated on a 96-well plate, and the optical density is read using spectrophotometer, and then the OD values are converted in viability values. Next, please. The viability values then are used to differentiate between corrosive and non-corrosive materials based on different cutoffs that were set up for each tissue model. Every skin has different cutoff values compared to the other 3 tissue models, and based on the viability of the tissues around these cutoff values, each test substance can be labeled either corrosive or non-corrosive. Next slide, please. The last method that can be used to assess the corrosive potential of test substances is Corrositex. It uses an artificial membrane that is designed to respond to corrosive substances similar to animal skin. The assay endpoint is the time in minutes that is required for a test substance to penetrate through the Corrositex biobarrier membrane and produce a color in the chemical detection system. As I said, the method is applied to assign UN packing groups to corrosives, and it can verify if a test substance is a non-corrosive. There is a limitation to this particular method because materials with pH of more than 4.5 or less than 8.5 generally do not qualify based on the chemical detection system included in the kit. The guideline was updated lastly in 2006. Next slide, please. These are the critical steps of the Corrositex assay. Usually the test substances are added to the chemical detection system containing vials to determine if they qualify for the assay. In general, as I said, a color change has to occur in order for the test substance to be qualified for the assay. If the substance qualifies, then it's added to 2 tubes to determine the appropriate timetable to be used for the packing group assignment based on the manufacturer's guidelines. A Category 1 test substance will be evaluated up to 4 hours, and a Category 2 test substance will be evaluated for up to 1 hour. As a next step, the biobarrier matrix powder is solubilized and added to membrane discs. The biobarrier membrane is then placed on the vials containing the chemical detection system. Each test substance to be tested is added onto 4 biobarrier membranes, and the vial is monitored for the first 10 minutes continuously. The process is repeated 3 times. If no color change occurs, the process is repeated 3 times until the remaining biobarrier membranes are treated with the test substance. The vials are observed until a color change occurs, and that is called breakthrough, and the time of the breakthrough is recorded. Based on the time that it takes for the breakthrough to occur, the test substances are assigned packing groups either in Category 1 or Category 2 based on the prediction model outlined in the slide. Next slide, please. Moving into skin irritation assessment, there is one assay that is validated for regulatory purposes. Next slide, please. The assay is called skin irritation test based on 4 tissue models from different manufacturers. Similarly to the corrosion assay, uses as endpoint the tissue viability assessed by the vital dye reduction MTT by viable cells. The results of this assay can be used for regulatory purposes to determine skin irritancy of test substances, either as a standalone replacement for the in vivo skin irritation test or as partial replacement test within a tiered testing strategy. One limitation of the assay is that it does not allow the classification of test substances to the optional GHS Category 3 or mild irritant. The guideline associated with this assay, 439, was updated last year. Next slide, please. As you can see in my slide, some of the steps are similar to the corrosion assay, so I'm going to outline or emphasize only the differences that occur in this particular assay compared to the corrosion. Usually tissues are received by the end user laboratory, and they are first incubated for 1 hour in their appropriate media. The media is then refreshed, and the tissues are incubated overnight in culture media to acclimate them. The assay uses triplicate tissues for each test substance or control. The test substance or control are applied for 1 hour to the tissues. After the exposure, tissues are rinsed and they are placed in standard culture conditions for up to 42 hours. However, the media is changed first after the 24 hours, and then the tissues are cultured for an additional 18 hours to complete the 42-hour post-exposure. The 42 hours are needed to capture delayed effects of the substances on skin. Next, the MTT reduction steps are performed similarly to the skin corrosion assay. The OD values are captured with a plate reader, and they are converted into viability values. The prediction model uses a 50% cutoff to categorize either category 2 skin irritant test substances or no category or non-irritant test substances. Next slide, please. I would like to conclude my presentation with a couple of thoughts about validated assays for skin corrosion and irritation endpoints, and I will present the strategies that are available for such purposes. In general, assays designed for regulatory purposes often rely either on a single exposure time or on a single dose, which provides a predictive response. And they are limited in their scope because they may not be useful for evaluating toxic effects outside the specific predictive range. They are frequently ingredient-oriented. Therefore, in the interest of both sound science and animal welfare, the in vivo testing should not take place until all available data relevant to the potential dermal corrosion and irritation of the test substance have been evaluated. Therefore, to employ a tier testing strategy, one can look at several sets of data. First, existing studies in humans or lab animals, evidence of corrosion and irritation that are structurally related to the test substances, data demonstrating extreme pH values, and results from validated and accepted in vitro or ex vivo tests. Next slide, please. These are the two possibilities of testing for skin corrosion and irritation potential, either starting from the top-down strategy on the left side of my slide or bottom-up strategy. For example, if a material is presumed corrosive based on data that are available previously, one can start and perform one of the in vitro corrosion assays. If the test substance is predicted to be corrosive, it's labeled as such, and the testing ends right there. If the test substance is not predicted corrosive, we don't know if it's going to be an irritant. So we have to start the bottom-up strategy, where we suppose that the test substance may be irritant. It's tested in an in vitro skin irritation assay. If the test substance is predicted an irritant, if it's predicted a non-irritant, then it's labeled as non-irritant. If it's predicted irritant, again, we don't know if it's going to be corrosive. So if we started from the bottom-up strategy, we may need to go back and confirm with the top-down strategy. These are all my slides. I thank you very much for your attention, and I'll be happy to take questions at the end. Thank you.
Okay. Thank you for listening to me tonight. I work for CAT Europe at the Center for Alternative to Animal Testing, which is located at the University of Constance in Germany and at the Johns Hopkins University. And CAT is very active in the development, promotion, and dissemination of 3R approach to science. I also work for RHE Mastery, where we prepare RHE registration dossier, so I have experience in risk assessment for that purpose. It's quite a fortunate position because I can adapt the academic approach into the practical need of the industry. Next, please. First of all, I'd like to show you some numbers just to have an idea of what we are talking about. This is the snapshot of the eChem portal, which permits the query among published data, including worldwide regulatory programs. The query is based either on a specific substance or by endpoint. By clicking chemical property data search, followed by skin irritation and either in vivo or in vitro and the reference year, it is possible to have an idea of how many new tests are performed per year. Next one, please. This is results that combine in vitro and in vivo methods to test skin irritation. The two peaks of the graph are clearly related to the two RHE deadlines, the first at the end of 2010 and the second one mid-2013. As you see, the number of in vitro tests is higher than in vivo now, but it also demonstrates that still the in vivo is very much used. Consider that we are talking about only on substances whose dossier has been published somewhere, and therefore many tests are not counted, as you can see in the next slide, please. This table shows the official statistics of animals that are used for scientific purpose in the European Union. In the area of toxicological evaluation, there are 3,000 rabbits that should correspond to about 1,000 new tests performed in the EU. This number is much higher than the data reported in the previous graph, as it counts any test performed in the EU for the purpose of skin irritation assessment. Beyond the rabbits, there are rats that is very unusually applied for skin irritation. Probably they are from dermal toxicity. Compared to other endpoints, this number is little, but in my opinion it's too much, considering that in vitro alternatives do exist and are fully accepted for regulatory purpose. Next one. Today I will talk about how skin irritation and corrosion can be assessed without the use of animals, and I will focus my contribution on RHE, which is the EU program for chemicals that was published in 2006. It was the first regulation which officially accepted non-standard method. The guidelines for testing strategies are now followed by other regulations in the EU, like that one on biocides or plant protection products, and also in other countries. Of course, skin irritation testing strategy is now well accepted in theory by all OECD countries. Next, please. When I work in RHE consortia and I propose in vitro tests instead of in vivo, I always receive this reply: negative results from in vitro tests are not accepted by regulators and must be always confirmed in vivo. This is a very common cliché that is so difficult to dismantle, even though it is completely false. Next, please. In fact, Annex 11 of RHE explains how non-standard methods can be applied. It is true that the first section of the paragraph says that negative results from an in vitro method must be confirmed in vivo, but after there is a list of conditions for waiving such confirmation. The first one regards validated method, and this is exactly the case for skin irritation and corrosion. Beyond that, there is also the opportunity of using results in weight of evidence mode or to justify a read-across approach. Next, please. The fact that negative results from an in vitro skin irritation assessment are fully accepted by regulator is confirmed by this ECA report that was published in 2010. On page 32 of that report, it's clearly written that negative results in the B46 test does not need to be confirmed by additional testing. I remind you that B46 is the transposition of the OECD 4-9 into EU regulation. Next, please. Actually, there are many other official documents to confirm this position, like, for example, this one again from ECA on skin irritation and corrosion, and that one from the JSC. That report is very well summarizes the state of the art of the alternative methods. My complaint is for Euclid, the software that is used for the preparation of RHE registration dossier, and which still has no dedicated pages for in vitro methods, but only for in vivo. And this may contribute to the idea that regulators do not fully accept in vitro tests, which is again not true. Next, please. As you know, OECD test guidelines are officially recognized as standard for testing methods. The OECD 404 is the guideline to perform in vivo tests for skin irritation on rabbits. It was published in 2002, so more than 12 years ago, and it contains a supplement describing the procedure to follow before applying the substance on living rabbits. Therefore, even if I claim to apply OECD 404 for in vivo method, I must follow those steps that are explicitly requested by the guideline. In 2002, in vivo test was mandatory to confirm negative results because at that time in vitro tests were not yet fully accepted. Excluding the last steps on rabbits, this is more or less what we do today for the definition of the skin irritation properties of a substance. Those steps are not strictly covered on that order, as usually a substance is evaluated globally in an increasing order of complexity. Next, please. Today, the principle of testing strategy for skin irritation is very well explained in details in this OECD guidance document that was published about 4 months ago, presenting the IATA, the integrated approach on testing and assessment for skin irritation. The IATA in this guidance is presented in modular approach. I strongly recommend you to study this document, which is very important. This guidance contains also an extensive list of references that can be very useful. I'm not going to repeat what's inside here, but rather want to present the procedure that we follow from a very practical perspective. Next, please. In the OECD 404, the very first step is always the evaluation of existing information. Data on humans can be available in particular from occupational exposure. Many chemicals that are now considered by RHE have been manufactured for years, and usually workers know very well if a substance is written or even worse, corrosive. Even if this information cannot be used because not supported by an official report, it is very important as it provides the idea of the property of the substance. Then there are existing in vivo studies. Generally, those studies are accepted even though with care, as in many cases they are very old, not GLP, and the identity of the tested substance is not very well defined. For the moment, it has never happened to me to find existing in vitro results. Let's see in the near future if something will change. Next, please. To gather all existing information, the first portal to look for is always ToxNet, which collects data from all those databases as shown on the right side of the slide. Gathering existing information is generally considered globally, including all physicochemical properties, dermal toxicity, but not only, because, for example, skin sensitization should not be ignored when considering skin irritation, as this effect may interfere, especially in vivo tests. It is also true that usually a new substance is always considered for all endpoints and not just for one endpoint like skin irritation. Regarding physicochemical property, the pH is of course the most relevant parameter, but others are useful like the outdoor water partitioning, the oxidizing capacity. As also mentioned in the OECD 203, for example, the presence of a peroxide group may lead to the conclusion that the substance is corrosive. Next, please. The TOXNet database considers also ChemID Plus that offers the opportunity to look for similar substances with the bottom on the right in terms of chemical structure or parent compounds like salts, hydrates, and so on. And this is very useful beyond the formal read-across approach. Next, please. Next up is the application of QSR model. This is a snapshot of the OECD toolbox, which is very useful and complete. I don't know how many of you had the opportunity to follow the previous webinar of the series when Grace Patlevitz explained the potential of this tool. This use of QSR models is absolutely not straightforward, and this gives me the opportunity to say that risk assessment is hardly ever performed by just one person, but a team of experts in the different sectors are always fundamental to get to a reliable conclusion. Next, please. So, what do we need? Why are we trying to assess skin irritation? We have evaluated existing information and we have consulted the QSR toolbox. So what else now? We must know what we need in the end and in which scope. According to CLP, skin irritation has three possibilities: not irritant, irritant, or corrosive. Those are the corresponding pictograms. In theory, there is another category, category 3, between H315 and not irritant. This intermediate category is still not defined in vitro, but it was not implemented by CLP with the explicit reason that the GHS itself specifies category 3 as optional due to the intrinsic variability of animal response. Next, please. In reality, what we do is to consider skin irritation always together with eye irritation. Even though there are few exceptions, eyes are more sensible than skin, and therefore it hardly ever happens, or even never, that skin irritation has a more severe category than eye irritation. This must be taken into account when setting a testing strategy. It can be very, very helpful. Remember that category 1, about severe skin burns and eye damage, is used for both skin and eye. The the most severe category has 3 subcategories that are very important for the definition of the packing group for the transport rules. The way to define these subcategories is explained in the OECD 203 and can be performed fully in vitro. Next, please. So I want to say something about the cost. Let's assume now that a new experimental test is necessary for the definition of the skin irritation potential. In theory, we could decide to go through all existing methods just to be sure. This is not a good idea because we must consider also the costs and time that are involved. The very right column of this table lists the average price collected from a couple of CROs in Italy. Actually, the real price can be very variable, so please don't look at that precisely. What I wanted to show is that in vitro methods are not cheap, unfortunately, and the in vivo test may be less expensive. This situation gets worse if more than one in vitro test is performed because the testing strategy was not applied properly. So this situation must be avoided with the optimization of the strategy. However, I think that the cost of conducting the in vitro tests will likely decrease in the future as more people will start using the method. Another opportunity for reducing the cost is the possibility of setting the in vitro procedure in-house. That is definitely easier than equipping a new facility with living animals. Next, please. This is an example of a strategy that tries to optimize both skin and eye irritation in a bottom-up approach, starting from skin irritation instead of corrosion. Please consider this only an example because any strategy must be always adapted to a specific system and for a specific need, including the information that is gained in the previous steps. At this stage, the substance is usually characterized enough to understand which is the best path to follow to avoid duplication of the test. I don't go into details here, as for example, the RHE test for irritation is not validated, so further consideration should be taken into account. And this will probably be shown in the next webinar on the 1st of December. The cross on the arrow is because the combined strategy of both skin and irritation prevents the confirmation of a test, as we will see in the following specific example. Next one, please. I will present the example of thioanisole. This substance was selected only because it was tested for both in vitro skin irritation and corrosion, and data are publicly available in the ECA database. Let's assume that we start from scratch and we need to decide something about this substance. First step is looking for information in ToxNet, but unfortunately there is nothing. You see that this substance is present in ChemID Plus, where we can look for similar substance, and there we found that thioanisole is similar to anisole. Next, please. Anisole is a well-known chemical, and the full registration dossier is available in the ECA database. Anisole is not classified as skin irritant, tested in vivo, even though there is the supplemental labeling warning about the possibility of irritation following repeated exposure. By going into the details of the in vivo study, anisole had a slightly irritating effect on rabbits, even though not enough to trigger the classification as skin irritant. Next, please. The analysis of the thioanisole with the QSAR toolbox returned no special warning. At this point, we can reasonably exclude the possibility that thioanisole is corrosive, but we cannot be sure whether it is irritant or not, and therefore testing is necessary. Next, please. It was tested with the reconstructed human epidermal model test, and the result was positive. So this means that thioanisole must be classified as a skin irritant. Next, please. Following our previous scheme, next test is for eye irritation with the BCOP method. The result may be ambiguous, just saying that it's not severely irritant. However, as this substance is already classified for skin, we can easily accept the classification also as eye irritant with no further testing. We are talking about a substance which is used as an intermediate. It's neither a topical cream or ingredient nor an eye drops ingredient. So this level of knowledge is enough. Of course, for other purposes, further investigation should have been necessary. Next, please. For me, the classification, the definition of the irritant properties of thioanisole was over. Anyhow, this substance was also tested for corrosion, and the result was, of course, negative. To conclude this example, I want to state again that animals may only be used as a last resort, and that positive and negative results are accepted by regulators. And this leads to a very reliable conclusion. This is not driven by ethical reason, but by better science. I hope that now you agree with me that the application of a testing strategy definitely increased the knowledge of a substance and the awareness of a possible hazard and risk, with the further advantage that the in vitro methods may turn out to be more human relevant than animal tests. Next, please. I stop now talking and I wait for questions. In my ballot for conclusions, I hope that you agree that the regulatory framework is very important. There is no unique instruction, and even simple tier strategy should be tailored to the specific substance and the specific use. Assessment of the substance should be, and it is always performed globally, not endpoint by endpoint. And the interpretation of all available results avoid just adding the conclusion from each single study report. So it's very difficult to consider one report after the other as islands. Cost and simplicity must be taken into consideration. And to conclude about the strategy, I must say that now it's, to me, too much based on expert judgment. We are trying to make it more objective, but still is not as easy. Thank you for the attention, and I am now ready for questions.
Oh, hello. Thank you, both of those speakers, Amelia and Constanza. Some of the questions are concerning the costs of these things. Constanza, you certainly did mention some costs there. Is there any more information that you can give us about the costs of these tests compared to, particularly to animal alternatives?
Yes, of course, costs are very much variable. I don't want to mention the names, but also the skin model make the difference. And it's unfortunately now in vivo tests are performed outside the European Union at a very low cost. But to me also the quality is very low because how the protocol is set is very, very important. I think this is one of the problems of the in vitro strategy, because to the cost of the test you must add all the work, the workload which is related to the setup of the strategy. And another difficulty lays in the fact that there are very few labs that are equipped to perform all the tests that you may need. So you must jump from one CRO to another to find where the best test is performed. But again, I hope that this is a transitional period, and then in the future the in vitro tests will be the routine, and so many more CROs will be equipped, and many industries will have its own in-house facility.
Okay, thank you for that. Here we've got a question about the reversibility of some of the effects in methods. Are there some discrepancies among in vivo methods? That would be perhaps best, I think, probably again to Amelia.
Could you repeat the question, Philip, please?
Yes, of course. We've had a question about the reversibility of some of these effects and discrepancies between in vitro and in vivo methods.
It's very difficult to capture in the in vitro assays the reversibility that we may see in the in vivo models, because that's a long assay. It's up to 28 days following the animals. Furthermore, I think the epiderm or the skin corrosion assay captures corrosives relatively well, because they penetrate really fast, and at that point reversibility is almost nearly impossible. For skin corrosion, though, the assays have been designed to capture some delayed effects, not reversibility, but delayed effects, because of the 42-hour post-exposure. So any test substance that may have penetrated the tissues within the 1 hour of exposure, or which are still remaining of the tissues on the tissues, may induce delayed effects. So I think we capture more than reversibility. It's rather difficult. I think maybe a longer assay, a longer in vitro assays may capture that, but we may need more than keratinocytes in the tissue model to do so.
Thank you. I mean, as well as costs, we've also had questions about the turnaround times of these tests as well, which I think will be obviously an important point to cover. you were mentioning that there as well. So how long will it take?
Answer that. So in general, we purchase the tissue models from the manufacturers. There is a 2 to 3 weeks notice to the manufacturer to reserve the tissues. Once they arrive at our facility, usually on a Tuesday, like today, the corrosion assays are relatively short. They can be wrapped up within a day or two. The skin irritation test can take a little longer because of the post-exposure period. So they can last from a Tuesday to a Wednesday to a Friday. So it's basically a 4-day assay. So they are relatively short assays compared to in vivo protocols. So within a week, we can provide the data to our clients.
Yes, delayed response which occurs in some animals, I gather. Are there these in vitro assays that can help understand that problem?
As I said, I believe skin irritation does that to some extent, yes. And it was designed like that for that particular purpose. Again, it's just 42-hour post-exposure compared to up to 28 days in the animal model.
How are in vitro tests supported financially in general by governments in the EU compared with in vivo?
I think that's for me, and unfortunately there is no financing for anybody, so neither in vitro nor in vivo as far as I know.
Nothing, no support at all. Okay.
No. And this, thank you for the question, because this is something that I want to push as well. I mean, to find a way to help industries that are trying something new with the in vitro methods. Like, for example, some fiscal advantages or whatever.
Mm-hmm. Another a question for Constanza. Can this strategy apply to UV-CB substances such as byproducts of the metal industry, such as slags?
Yes, that's UVCB can be considered like mixtures, and some in vitro methods are accepted for mixtures as well. Of course, the strategy it's a little bit more complicated, but it can be adapted.
Thank you. Given the QSAR for anisole and the BCOP data, Constanza, how can you rule out that the positive RHE was not a false positive for thioanisole?
No, anisole was fully tested, and it's a very old chemicals. We are talking about thioanisole, and I'm sorry that probably I went, I mean, the study of the strategy is very long and they did it very quickly. But from the physical chemical point of view, you can see the thioanisole is definitely not very much active, and so the application of the in vitro method is positive, and it's reasonably accepted. There is no reason why to think if it's a false negative. And that's also supported by the somehow positive results from the BCOP. I have agreed with you that it would have been a suspicious result if the BCOP was below 3%, so demonstrating that it's fully real negative, but that was not the case. And for me, to me, it's not by chance, it's science.
Okay. I think you mentioned false positive. Do you know anything about the false positive rates of in vitro testing?
I mean, there is almost no false positive. I mean, the validation study demonstrates that the performance of the in vitro methods are very high, and please consider that the in vivo methods has never been validated, so we don't know whether the in vivo tests return either false positive or negative results. So in this sense, the in vitro is much more reliable.
Okay. A question here about in vitro methods being used for classifying mixtures, particularly with extreme pH, acid or alkaline. Are there tests that are not suitable at all for this category?
Depending on the pHs, some of the materials can qualify for Corrositex, so that can be done, and the UN packing group can be assigned. Sometimes, depending on the extreme pHs, particularly high pHs, skin corrosion assays can be a little bit challenging. But I think between the two assays, we should find one that could be used for classify even high extreme pH product mixtures.
Okay. We have another question here about validation of in vitro tests. How are the tests validated? Are they validated against human data? Or are they validated? Are they not? Well, how are they validated? I can answer that question to some extent, and maybe Costanza can help as well. As far as we know from the in vitro assays we discussed today and many others, they are validated against available in vivo data. So, it's still a question how the in vivo data, animal data, rabbit or else, is relevant to the human system. So what happens if a human is exposed to a certain test substance? So that's still questionable. But the validation is performed against animal data. Okay. Are there any specific chemistries where these epiocular and epiderm tests would provide false positive or false negative results?
The validation of these methods covered a relatively wide spectrum of ingredients, because they were validated against ingredients. For specific test substances, we can anybody can go to the OECD guideline to see what was overpredicted or underpredicted. Nothing really comes to mind as a category. As I said, it could be some extreme pHs or certain chemistries. Maybe they were not used in the validation. It was difficult to capture all classes of chemicals. So there may be some that are classically not predicted correctly but not included in the validation. So until we do it, we may not know. If industry has data to share, I know it's more difficult to publish, but if industry could share of their experience with certain classes that are not correctly predicted, that would help us move forward the field much faster, I think.
If I may add, for example, a substance can interfere with some reactive that are used with the in vitro methods, but the advantage is that any sort of interference can be measured, and please consider that also in vivo color substances or sensitizer can be very difficultly assessed on rabbits. So it's a type of problem that's common to any test.
Thank you. I think perhaps there's time for one more question. I think I might put this one here, which is, I think, maybe a heartfelt question. what can you do to teach students in natural sciences that the in vitro methods are valid and there's a need for the end of animal testing?
I think I can answer part of that. Certainly at IIDS we are involved in education activities yearly, and I think presenting both sets of data, in vitro and in vivo, for any given assay that were available for validation would make a very strong point, you know, to support the in vitro assays as a replacement of the in vivo. So presenting clear data, sets of data, would help to get a direct comparison between the in vivo and in vitro.
Thank you. Thank you. Anything more, Constanza? Or?
No, nothing. Just training is enough. I think that in vitro methods are still very not explained at the university, so dissemination is a very, very important issue.
Yes, indeed. Well, thank you very much for that. It's just turned 5 o'clock. I think it is time to wrap things up. I'd like to say a big thank you to all of our speakers, to Amy, to Amelia and Constanza, to PETA International Science Consortium, and also the delegates too for participating and making the webinar a big success. We have around 720 delegates signed up to this event, so it's very good. The best of luck to you all as you go about your work in this field. Thank you and goodbye.
Thank you. Goodbye.
Thank you. Bye-bye.